Today we're going to talk about how to install the BigTreeTech TMC2208 UART on the BigTreeTech GTR version 1.0. Now I need to review a couple of things real quick here. We have our X stepper, our Y stepper, our Z stepper, our E0 stepper, our E1 stepper, and our E2 stepper. These are used for extrusion. Now, one of the things that they do when the board arrives is they deliver it with SPI pins already attached. So we're going to have to pop these out. So I'm going to do that real quick over here. So these are for the Y-axis that I'm taking them out. And this is for the X-axis. Might take a second because apparently I can't get the pick in there. There we go. Unfortunately, I wish my fingers were tiny right now, but apparently they're not. Okay, so now that we have those removed, we have to understand one other thing about these steppers before we check the manual, and that's the enable pin and where it's located. So it's located for here on the X, here for the Y, here for the Z, here for E0, here for E1, and here for E2. So here's the manual for the GTR version 1.0. It's operating instructions, as you can see. So let's scroll down a bit here. It's probably going to take a second and see where we can set the actual jumpers. So now they're talking about the board, and now we're getting down to the nitty-gritty. Okay, so right here it says mode interface description. So in my previous video, I showed you how to do step dir for the A4988 and the DRV8825. But further down, they talk about UART. So UART is unique in that they show you where the jumper is going to go. So as you can see right down here, UART mode, it says when using UART mode, you will need to connect the pins in yellow. And so they show the boxes down here. So there's a pin here, 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 and here. Let's take a look at the board again, see if we can find those. Okay, as you can see on the board, we have over here the X UART and the Y UART. And you can see labeling on the silk screen down below. And that says the Y UART. So what I'm going to do is I'm going to actually place this, hopefully with the dental pick, in the right position due to the nature of the board here. It's kind of hard to get this one in. So hopefully in a second I'll actually be able to place this. There we go. And so as you can see, it's on that pin, so we're going to push it down. And now we're going to do the Y UART. And that one is the same process, except now we don't have a fuse in the way. So we just take our jumper, place it on top like so, and then apply a little bit of pressure to put it in place. Okay, here's an extreme close-up of the BigTreeTech TMC2208 version 3.0. Now, as you can see in the upper right-hand corner, there's a pin that says EN next to it. Now, if you haven't noticed, EN stands for enable, and that's what we need to orient our stepper correctly. Also in the upper left-hand corner, we have a direction pin, and then down here we have a ground pin. Now a couple other things of note, this gold area is where the heat is designed to wick through the actual board, and we'll be placing a set of heat fins on it. Now, I also recommend running a fan continuously when these are running on these steppers, because that way they'll keep them cool and they won't burn out. Now, there is another thing right here, and that is a trim pod. The trim pod is not really used in this tutorial, and you'll probably never need to use it on this stepper, because we're going to be controlling the actual stepping via the Marlin firmware. And finally, in order to place this in the board, what we need to do is, obviously, we know where the enable pin is. It's in the bottom left-hand corner. So we're going to place it over our stepper port, and then we're going to apply some thumb pressure to put it in place. Now, a good little hint as well is, you can see there's a red dashed set of pins over here, and then we also have black pins on the other side. That's another key to help you insert these correctly. So we're going to place that down with a little bit of pressure, and now we're going to set it up to load the firmware. So in order to do that, we need to do a couple of things. First, we need to move our jumper over here over to the next two set of pins, and then apply a little bit of pressure to put it in place. This will allow us to connect via USB for power. Then what we're going to do is we're going to pop out the actual SD or micro SD port right here. So it slides right out, and we're going to place this in our micro SD drive adapter so that we can fit it into our computer. And you may hear a beep when I connect this. Okay, first things first, as you can see, we have the SD card inserted in the computer, and it says firmware.cur. In this case, it means current, for the current firmware, and this means that, being in all capital letters, that it was the last loaded firmware. So what we're going to do is we're going to open up Visual Studio Code, and I've already unzipped the actual software for Marlin. I'll leave a link in the description. So I'll show you how to actually load it. So I'm going to click over here on Explorer. Then I'm going to go to Open Folder. Inside Open Folder, I'm going to go to my Marlin 2.0. And there'll be another Marlin 2.0 inside there. And then I will click Select Folder. Now that I have that open, what I need to do is, first of all, find our board. So I'm going to go to Marlin, then I'm going to go to Source, then I'm going to go to Core, then I'm going to open up boards.h. Inside boards.h, I'm going to do a search on BTR underscore, and of course, I'm doing it wrong here, so it's actually GTR underscore V1, and that brings us to the board that we're using. So I'm going to copy that. And over here, a little hint, they use the actual chipset information. It's not really a value in this category, but at least you know what it is. So I'm going to close out of Core, Source. I'm then going to close boards.h, and then I'm going to go to configuration.h, and I'm going to do a search on motherboard. Inside here, I'm going to rename the ramps version here by pasting over what we just copied. I'm also going to change this up here to -1. And then finally, what I want to do is I want to find our particular stepper. So I'm going to click on Control F, and I'm going to say A4988, and that'll bring us to steppers. Now, seeing how we're only using X and Y for our stepper drivers, and these have comments in front of them, we need to remove those comments. So I'm going to backspace to enable it, I'm going to do the same thing for Y. And then for good practice, we might as well do Z and E0. Those are the most commonly used. If you have other steppers, of course you're going to uncomment them, because the GTR with the M5 combination actually has several steppers. So as you can see, you could probably add a ton of different extruders, or possibly other Y or Z or X axes. So now that we've got those selected, the next problem that we have is that we have the wrong stepper specified. We're using a TMC2208. So what I'm going to do is I'm actually going to find the TMC2208. I'm going to copy that, and then I'm going to paste it here and here. Now, if you haven't watched my previous tutorial on the DRV8825 and A4988, you may need to watch that to understand what I'm about to do next. But let me see if I can explain it as best as I can and as short as I can. Down here, we have default axis steps per unit. Now the problem with this is these are default, so we need to find the correct ones. We need to go over to our browser and open this up, and we need to go to RepRap Calculator. And RepRap Calculator will allow us to understand what we need to set. So down here they talk about filament, but we're interested in the belt driven system right now, which is the x-axis and y-axis. Most people use a 1.8 degree of stepper. That would be your NEMA 17. And then what I had talked about in the previous tutorial was 1/16 of a step and 1/32 of a step. So I need to show you something because it's not computed for anything above that. And because the TMC2208 can do between 1/16 of a step all the way up to 1/256 of a step, we need to understand what we're doing. So over here, if you had a pulley that had 8 teeth, then it would be 200 steps that we would need to get. So in this case, what we're going to see is what the proportion change is, because at 1/32 it's 400 steps with this default. So what I'm going to do is I'm actually going to say, okay, we're going to do 1/64 of a step. So instead of 400, it would be 800. So we're going to go over to VS Code, and we're actually going to change the 80 to 800 for 1/64 of a step. And this will make sense in a moment, but that's all we need to do to set up for our stepper at the moment. So I'm going to go over to configuration advanced.h, and I'm going to do a search on 800 so I can get to the category real quick so you can see what I'm talking about. So down here we have our X current. Right now it's set to 800. This will be dependent upon root mean square, which is a calculation that you'll need to use your data sheet for the TMC2208 and possibly your NEMA stepper to configure correctly. But for now, I'm going to leave it default. And resistor sense, I believe, is another factor that you're going to have to look up, but I believe this is always going to be this value in this case. But over here, this is where I was talking about the 800. Right now it's set to 1/16 of a step. We need to change this to 64 in order to get the correct value. And then we need to do the same for our Y axis down here. So 64 as well. Now, as you may have noticed, there are additional axes that you can work with, or axes, and these are all listed the same below. Keep that in mind in case you need to change those for yourself. Now there's other values that I want to show you for changing in this configuration file. And the first thing I want to show you is, let's see, monitor. And what this is monitor driver status. This is a debugging tool that you can use to make sure that your steppers are functioning correctly. So I'm going to backspace to remove the comments, and that's going to enable this so that we can actually use it, because we need the M122 G code in order to test or report the driver's status. So I'm going to scroll down, and I'm also going to find TMC debugging because we need that as well to run this. So here is TMC debug. So I'm going to remove the comment as well, and that allows us to actually set up our debugging. Now there's functionality that I'm not talking about with this stepper at the moment, because I'm assuming either you know it or you can look it up, that explains how it works. There are other settings that are going to be around this area that you can actually set for your steppers. I'm really not going to cover that right now because hybrid threshold is something that's somewhat advanced. Obviously, it's commented out for now, and there are other things that you could set. So that I'll leave to you to figure out. But now what I need to do is set up the actual building of the actual install for the firmware. So in this case, we need to find our chipset that we're using for the GTR version 1.0. So I'm going to do a search on GTR _ V, and that'll bring us to the environment that we're working with. So I'm going to copy that. Then I'm going to go all the way back up to the top, and I'm going to paste it over the Mega 2560 because we're not using that default environment chipset. So I'm going to paste it right here. And then in order to actually build this, we need to click the build button. And what occurs is actually a compile. And then we can actually grab that. It'll be in our .pio folder. If it doesn't exist already in your configuration, it will exist if the build goes correctly now. So I'll click this and then I'll show you what to do. Now that it's finished building or compiling, you can see that it took about 5 minutes and 57 seconds, but it was successful. So we're going to go over to .pio and open that folder, then go to build. Then we're going to go to the BigTree GTR version 1.0, and we're going to right click and say reveal and explorer. Inside there, we're going to open the folder, and then down here we have our build. So I'm going to right click on that, and I'm going to do send to SD card. So I'm going to click on the SD card, as you can see over here, and now we have a second firmware, and it's .bin. That's for binary. So I'm going to remove this and show you how to place it back in the GTR. So I have the micro adapter here for the SD. I'm going to pop out the SD for the micro SD card, and I'm going to place it inside here. Now, once again, the jumper is relevant for this because we're going to apply power to it. So I'm going to connect the big side of the USB serial cable to the board right over here. And the small side is going to be connected to the computer so we can power it. And as you can see, the green flashing light is loading the firmware. Off camera, I connected the power for both the motors and the logic of the board. It's 12 volts of power. And I also connected the motors. Now keep in mind with the motors, If it's going the wrong direction, you may have to invert the direction in the Marlin firmware. That's on configuration.h. And the other thing is, now that we have power connected but not energized, we need to move over the jumper so that we can power it. So I'm going to move it right here, and that'll allow us to actually power our board. So I'm going to actually energize the system after I connect the serial USB cable. So what I'm going to do is I'm actually going to take the connection for USB and reconnect it to the board. And not much will happen because it's not powered by USB anymore. So you'll just see a light. Now I'm going to actually energize the board so we can test it in Pronterface. So finally, we're going to test this. So in the print run directory, I have Pronterface executable. I'm going to open that. Then I'm going to connect to the printer. And as you can see, it says that the printer is now online. And I'm going to type the G code M122 and press enter. And as you can see, it's doing testing of the actual steppers right in here. And it says what your settings are. So this means that they're okay because we're now under power. And so now we need to test it. So for the X stepper, I'm going to move 10 millimeters. Now I'm going to move 10 millimeters for the Y stepper. And that appears to be okay. So let's try 100. And then 100 for the Y stepper. And just so you know, no one is paying me or sponsoring me to do these tutorials, and I purchased all of the equipment with my own money, but I will be placing Amazon affiliate links in the description for your convenience. And as some people have discovered, I now have a Discord that makes it easier to communicate with me in case YouTube has issues with their comments field. So I want to take a moment to thank you for watching my tutorial, and have a nice day.